Alright, the other sample that we're going to use, the other sample distribution, is going to be for qualitative data, which we deal with proportions. The binomial is what we used previously, so sample proportion is going to work very much like that. The notation for that sample proportion is P with a little caret on top. It's called P hat, looks like it's wearing a hat, and it's calculated by taking x and dividing by n. X is the number of individuals in a sample with whatever the characteristics are. So if we interview 150 people and ask them how many of them drink soda, and 40 of them said they do, our p hat would be 40, which is x, the number of people who agreed with whatever we were talking about, in this case drinking soda, and dividing by the total amount of people tested, subjects, whatever, and that's n, in that case 150. So p hat is going to be used to estimate the population proportion p. The sampling distribution of p hat is going to work in a very similar manner that the one for x bar did. It's not surprising that the mean of the sampling distribution for p hat is just p. That's what we expect it to be. So the expectation of p hat is simply p. Now the standard deviation is a little bit more convoluted, so this is going to equal p times the complement of p, which is q, or 1 minus p, divided by n. We're going to take the square root of that. So sigma of p hat is the square root of p times q over n. Now for n to be sufficiently large, and use our central limit theorem to indicate a normal distribution can be used, this is the rule. So both n times p hat must be at least 15, and n times q hat must be at least 15. Now a clever math student can realize that whichever is smaller of p hat and q hat can be multiplied by n, and if that value is at least 15, then certainly the other value will be. But I will show you an example with both in there. Alright, so here's our example. If the actual proportion of people that believe in global warming is 0.7, then we're trying to find out the probability that a random sample of 100 people who are asked the question has 72 or more people believe in global warming. So basically we're looking for this probability here, the probability that our p hat is going to be greater than 0.72. You can put an equal to sign there, but again we're going to use a normal distribution, and the probability that it's exactly 0.72 is 0. Now we want the mean of p hat, and the mean of p hat is simply p, which in this case is 0.7. The standard deviation of p hat is equal to the square root of p times q over n. And that equals, we're looking at 0.7 times 1 minus 0.7 is 0.3, and n is 100. And I'll calculate that in a minute, but what we want to do in order to be able to use the normal distribution here, we have to check to see if n times p hat and n times q hat are both at least 15. So let's do that. N p hat is 100 times 0.7, and that is equal to 70. That is certainly at least 15. Similarly, n times q hat is our 100 times 0.3, or 30. Still over 15. Now again, as I mentioned, you can take the smaller value of the p hat or q hat, determine if that times n is at least 15, and then clearly it'll work for the other one. Alright, well we're going to need to calculate this value here, and for that I'm going to need a calculator. Alright, So typically when I have this, you can put the whole thing under the radical if you want. I typically calculate what's inside it first and then take the square root. That's up to you. So 0.7 times 0.3 divided by 100. So that's my value inside the radical. I'm going to raise to the power. This caret raises to the power. And I'm going to raise it to the 0.5 if you want to. It means square root. Square root is the 1/2 power. I'm raising my answer to the 1/2 power. So that's what this equals, 0.0458 or thereabouts. Now, if I want to calculate this probability here, I need to use the normal CDF function. I've now proven that I can use the normal distribution. I have a low value, which is 0.72. I'm going strictly greater than, so my high value is E99. I have a mean, and I have a standard deviation. I'm going to leave it like this because I'm going to input this answer into the standard deviation to get an exact value. So second var's normal CDF will get me to that. My low again is 0.72, comma, my high is the second comma, which is E99. The mean is 0.7, and the standard deviation, I'm going to put the answer of the previous value in. So this is what's going to populate that. So the probability of this comes out to about 0.331. So that's not very unusual. That's certainly a value that's pretty high, certainly not lower than 0.05, which we kind of consider the unusual threshold. But this is how we use the proportion P hat and can calculate probabilities with it.